Mr. C here again, third video. Okay, hey guys, I forgot to bring up something when we were talking about stream erosion, and that's what is the necessary speed of a stream, the velocity of the water to get things moving for each sediment size. Once again, growing up, I thought that a piece of sand was different than a piece of silt because it was a different rock. Nothing to do with that. It's like shirt sizes. All different sizes are different sediment classifications. So what we have is a chart right here. You got, okay, 0.004, 0004 all the way up to 0.006, your silt. Less than that, your clay, sand, pebbles, cobbles, boulders. You don't have to memorize things like the dorky earth science teacher that I am. You could just look it up right here on the chart and get it. Now, so how fast to move the smallest pebble does a stream have to be moving? Well, a stream has to be moving, right here is the smallest, actually, let's say the smallest cobble, not pebble, cobble. And how fast is that? Well, that pretty much, and you can go up or down on the chart, that's pretty much the first little mark. And if this is 100 and that's 500, these aren't linear here changes. They're sort of exponential changes. And anyways, that's going to be where 200. So 200 centimeters per second. Well, what is that? 200 centimeters per second is 200 of these bad boys, okay, per second. That's pretty fast. The water up at the Ottawa River that we've been traveling in and been going to for the last 22 years can sometimes go over 2,000 centimeters per second. So it's a little bit faster. You're able to move definitely boulders, at least at the bottom. And if you do see a boulder flying in the water with you, you should probably get out of the water at that time. Okay, but anyways, so we need about 200. So what about the smallest pebble? The smallest pebble, what's necessary to move the smallest pebble? And all other pebbles thereafter. Well, we're about right there. Okay, and what is that? It looks like it's about 50. That's about 50 centimeters per second. So if the water goes less than 50 centimeters per second and you're a pebble, what's going to happen? You're going to stop moving and you're going to deposit. Would that be on the inside of the curve or the outside of the curve? I should say meander. Of course, that's going to be on the inside because the water's cruising along the outside just like you are when you're in a water slide. And let's say you get to the end of a stream. What's going to happen to the water speed? The water velocity is going to slow down. And as the water velocity slows down, so are all the sediments in it. So the first things that are going to settle, if there are boulders, is going to be boulders, and then cobbles, and then pebbles. And that's going to be that horizontal sorting. Here's a stream, empties out into a larger body of water. Big stuff first, smaller, 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 and the smallest way out there. A little bit of that, like I said, horizontal sorting. All right, we're ready for the next stuff. Here I get discussing again. Okay, don't show anybody. All right, we are going to do now, got to turn on the projector, got to find the controller, it's right here. And right now we're going to do a little bit on wind and ocean water, I should say shoreline, beach, erosion and deposition. All right, we're going to turn this off, and here we go. All right, with wind, first of all, what is the appearance of the sediment? Well, with streams, it's really, really rounded, okay? But when it comes with wind, you're going to get like a pitted appearance to it. I'm going to move this out of the way so you guys can see this a little bit better. It's going to be pitted. The types of erosion are the scraping, which is called the abrasion. Thank you very much, assistant. And also, what's going to happen is, close to the ground, you're going to get more action of that sediment hitting the rocks, and you get things like balancing rocks, because that's where most of the sediment, the loose sand, is sand blasting away. I mean, that could be a very, very powerful thing. If you were like tied to a post, okay, out in the desert, and you get a little sand in your eye one day, let's say you can't rub your eyes, your hands are tied for some reason, maybe you're a thief and they want you to suffer. Well, anyways, I mean, after probably about 3 or 4 days, you're probably not going to have any eyeballs left. It's going to be that nasty. Sand is really sand blasting material. That's why it's called sand blasting. In fact, out in Las Vegas, what they do is around the telephone poles, I was thinking I maybe had that up there, around the telephone poles they stack up rocks. In fact, I think I do have it up there. Let's see. No, that's okay. Let's go back. All right, around telephone poles and stuff, they'll stack up rocks to protect the telephone poles from getting chewed down like some beaver was working on the bottom of them, but actually it's sand, so they got to protect it. So this, Why is this thing, which by the way is called the cowboy, there's the belt, there's the Levi jeans, there's his butt, that's the flare leg coming out the bottom. Okay, that's out in Arches National Park. Why do the legs stay and the rest disappears? This is called differential erosion. It just so happens that sometimes the sand gets packed a little bit more than it does at certain areas than at others. And you're going to have this, these particles are weaker, they go away, these particles stay. You know, it's just like snow in the front of your yard at the end of the winter. Some of it stays, some of it's gone. It's sometimes a little bit more packed, stuff like that. Same thing with the balancing rocks and arches. There we go. Deflation is also when sand leaves the area. Okay, let's go back to that deflation. What happens is sand actually blows out of an area, eventually gets down to the water table, and you get something like an oasis. That's called deflation. Usually we equate deflation with letting the air out. This is letting the sand out. And another thing that's depositional when it comes to sand, or when it comes to wind, is sorted deposition, which means layers and layers of sand. Sometimes all silt, sometimes all sand, sometimes all silt, silt, sand, depending on how windy it is, what kind of particles are going to get deposited. Now, two different forms of sand dunes that you guys have to know. The first form is called the barcon. With the barcon, it's kind of like a skateboard ramp. The sand's going to go off. What's going to happen is this is the gentle slope, there's the steep slope at the back end. You wouldn't skateboard up this unless you were going to do a jump. So what you want to do is you want to go up the gentle side. These are the barcon. This is when you have lots of sand. These are called parabolic. Parabolic form when you get a bunch of vegetation holding the sand in place, like little cacti and stuff like that. And what happens is the actual hollowed out area is the front part, and it's the steep area instead of the gentle one. This is the one you're most often tested on, the flat with going off the steep head. Now, as far as wave erosion, I actually took a picture just like this. This is Australia along the southern coast between Australia and the Tasman Sea. This is called the 12 Apostles. You know what's really funky about this? At one point, this whole cliff was all the way out to here. What has happened? Waves have crashed against this unabated. Whenever you have waves crashing against the shore, they're going to tear it up. A little frost wedging going on too, okay, physical weathering, and you're going to get what's called these sea stacks. They're the things that are left over millions of years, basically, of unabated waves hitting the cliffs, and actually what it forms is sea cliffs. But sometimes you get deposition. Deposition is when the water's caused to slow. This is really cool. This is not far from us, being that we live in Buffalo. This is Erie, Pennsylvania. This is a place called Presque Isle. In Presque Isle, they have these things called breakwalls, which, by the way, you guys got to go to Presque Isle. It was rated at one of the top lakeside beaches in the United States. And it's right here in our backyard, basically about an hour and a half away. These little breakwalls stop the waves from coming in full speed, and what happens, behind each breakwall, you have deposition because it's protected. Where the water goes through, it erodes. Pretty simple stuff. If the water's going through at full speed, it erodes. If the water is being stopped, it's going to cause deposition. Just like against what these things are called, they're called jetties or groins, where they stick out. So you have this thing called a longshore current, and what it does, it's going to build up sediment here. It's going to build up sediment here along the side where it's pushing into the groin, and it's going to take it a little bit away, build it up again, take it a little bit away, build it up, and that's how you can see the water coming in, building it up, taking it away, building it up, taking it away, building it up, because it gets blocked off, and here's a groin in real life in addition. Also, I don't know if you recognize this, but this is Cape Cod. Cape Cod has two things going on. It's got wave deposition, forming what's called a spit there due to the currents, and it also has a lot of unsorted sediment deposition, but that's for the next topic.